So today we have our guest speaker, Mr. Anish Kumar. So he comes up with an in-depth knowledge and expertise in the area of artificial intelligence. He is specifically having an exemplary track records in generative AI domain. He currently serves as the AI software engineering manager in Intel Bangalore. So I'm definite we are going to gather a lot of insights today and there will be a significant amount of information from the session. So let's have start with the session. Good morning and welcome once again, sir. Over to you, sir. Yes. Thank you.
Good morning, everyone. Thanks for joining us today here, and it's quite honor to be joining this session here, delivering a session on generative AI industrial use cases. So before I begin my journey, today's talk, I would like to start off with a small recall of an incident that happened maybe 10 or 11 years ago when I was working in a startup. Back then, the startup had just got Series C funding of around $72 million. And we started off with a Kickstart meeting in California. And our founder, after all the kickoff meeting, he took us to a ride and he had his brand new Lexus SUV. It's a huge machine, right? He's a huge top end SUV, Lexus SUV. While driving, he was explaining some of the features that the Lexus had. So at that point in time, he was explaining that the Lexus had this lane assist key, lane assist, automatic emergency braking, and the lane keep, and all this advanced what we call as ADAS features. All those features would have it in the Lexus. And he was like very proudly explaining all these features are available and he used to demonstrate. Like he used to leave the hand from the steering and it used to maintain the driving and all the stuff and it used to brake, it used to slow down. And like it was a proud feeling for him also because it was a brand new SUV and he was also demonstrating all these features. And now, if you look back 10 years, I would like to reconnect, connect how the generative AI is going to also shape some of the things that we are talking today. And probably will, when I come back there, I'll reconnect this story and see how things will be impacting us. So before I go there, brief introduction. I think Devasis introduced me, but let me get into the depth of it. So myself, Anish, and I have over 2 decades of experience in the software industry. Currently, I'm the software engineering manager at Intel, handling all the customers in the Asia Pacific region. So as part of my role, we actually help customers that comes to Intel to optimize their AI solutions right from ideation stage to production stage. Even after this workshop, if you have any AI-related use cases and you want any help in developing your AI, so it might be in addition stage or anywhere between addition and production. And if you need help, Intel's help in optimizing it and selecting better hardware and the software features, do come to us. My team is there, my Intel engineering team is there to help you there in that journey. So as part of all this entire engineering effort, Intel also does a lot of workshops and trainings like this. This is one of the workshops. We also do a lot of hackathons. So last time when I was in IISc, we had a hackathon here. And that's when I met the Devasis and got to know and today we are here talking about this, right? So with that introduction, we'll go to the agenda. So agenda is simple. We'll talk about 2 things. We'll talk about generative AI and then we will cover some industry-specific use cases. From a generative AI perspective, we'll see how it is evolving and what are its impact and what is the way forward for the generative AI, right? Impact for you and me or impact for the general public or the impact in the market. What is the impact it's going to have? So one common thing everybody will be seeing is how many of you are using, I think everybody will be using ChatGPT at least once or at least you are aware of ChatGPT, right? So if you have heard of ChatGPT or used ChatGPT, it has been somewhere around the mid 2020. What happened was when the ChatGPT was released, it had around 175 billion parameters. That's the model that was being used by ChatGPT in mid 2020. And that 175 billion parameters had all the data from all the written human history, from the beginning of human history till that around 2020, whatever was there, it almost had all those things compressed in that 175 billion parameters, right? So that's the evolution of, that's how the publicly available ChatGPT was knowledgeable. Now if you see, and then we are currently, I think it's in the ChatGPT 4, 5 is also there. I think publicly it's not yet available. Probably pretty soon we'll have a ChatGPT 5. ChatGPT 4 is publicly available. It's around 1 trillion parameters. That's the kind of parameters. So you can see exponentially this charts is keep growing. The number of parameters that are being embedded inside these models is keep growing. So I might be introducing a lot of these technology terms. So let's have an interactive session. If you have any questions at any point of time, feel free to raise your hand and we can have an interactive session as well, right? So what I'm saying is all these parameters and all this model size is increasing, model's complexity is increasing, right? And if you see what is the cost involved, ChatGPT 3, when it was released to the public domain, it took almost more than 16,000 GPUs running more than 6 months, continuously 24 by 7, running for more than 6 months to train ChatGPT 3. And what was the cost involved? It involved around $1.65 million to train that model. And then we have this ChatGPT 4, which is taking around $40 million. So the amount of money involved in training and inferencing this kind of huge models is huge. So it might be practically impossible for most organizations, most enterprises to actually develop their own model, right? Or to work on their own models. From the inferencing perspective, ChatGPT is spending almost $40 million to process 100 million inferencing requests. Every time you put a prompt in your ChatGPT console, and for every 100 million active users, it's actually spending around $40 million. And current estimate for doing this around $4 billion. These are all huge money, right? These are all huge money, huge hardware cost, huge power consumption, huge impact on the environment. So we need to be always be aware of all this. Since you're all now getting into and trying to understand, you also need to understand the perspective, not only how to develop things. You need to also understand the impact, the overall kind of broader impact this AI is going to have. Right? So if we see traditional AI, let's say before generative AI, the traditional classical AI ML, classical AI ML, what used to happen is mostly was kind of impacting non-skilled workers. So let's say, for example, let's say we have this air conditioning in here in this audio room, right? I might want to automate this entire air conditioning. So probably I'll say take some room temperature and maybe say outside climatic conditions, everything. That takes 6 months worth of data, maybe train a simple model regression model or some simple models, and use that simple modeling to actually develop an algorithm that can actually switch on and off these air conditioning and set the temperatures. And this kind of models, while the classical AI models, used to impact mostly non-skilled workers. So non-skilled workers who doesn't need any big educations or big technical things, right? Those kinds of jobs were being impacted with all this classical AI ML. Now with the advent of generative AI, what generative AI does is generative AI can actually generate brand new content, right? Content that never existed at all. It can actually go ahead and generate that content. That actually brings directly all the skilled workers like you and me into the line of in this line of fire, right? So today we have models, generative models that can generate a code. I know there are many developers who, for example, one of the developers, if they didn't know anything about SQL, right, like SQL coding, they know very basic SQL coding. But what they can do is they can actually use Copilot. How many of you are aware of Copilot? So Copilot is an enterprise grade paid version of AI model that can help you generate codes for you, right? You can you can ask a prompt like, I want to join this two table with this result. It can actually generate an entire SQL for you, or it can generate a Python code for you, right? But there are also open source versions of those kind of models like Code Llama, Star Coder, and other things. Probably I will recommend, since you're all learning something new, instead of going directly with Copilot or ChatGPT, try to use open source models, right? Use open source models. And this models now is going to actually give a competition to me, to you and me, right? Like, so the only difference between a fresher and myself is I have accumulated this 20 years of knowledge, right? I have this various experience on how to deal with all these various types of coding and things like that. Now, the fresher, if he is able to ask a very good question to the model can give a better answer than probably a 20-year experienced guy can actually generate a code, right? And that too, it generates within seconds. You don't have to spend days or hours together to do these things, right? So that actually directly tells us that our skilled jobs are at stake. In fact, many of my Impulse customers are already developing to a lot of platforms that probably you might see another 3 months or 6 months or maximum 1 year down the line. These huge enterprises are already going to deploy platforms that is going to generate the code for you, right? You might just have to feed the project requirements to it, and it will generate the entire, at least 90% or 80% of the project template will be generated. Like then an experienced guy will go and just look around the overall things and then probably make some minor corrections and get it to deployment. So that's the kind of challenge it gives. So obviously brings a concern for you and me whether this is actually going to be a threat, whether there will be a reduction in software engineering jobs, right? So tomorrow, instead of companies like big enterprises, I don't want to take any names, but you know all the big companies, right? If a big company wants, I assume that currently they are hiring 25,000 freshers every year. Will they reduce it to say 5,000 or maybe hundreds of engineers every year? Because now these models can generate the code. Well, I will differ again. We don't know. We can't predict the market. But let's see how technology has been evolving all these years. Right? We are talking about the evolution. So now connect back the story of the Nexus story that I was telling. So in just 11 years ago, the ADAS systems of the lane assist, keeping the lane assist or automatic emergency braking, this was a very premium feature which only a startup founder who has just got some millions of dollars can afford to buy. Right? That was the kind of feature. This was a premium feature he was able to tell us. Now, today, if you go to a Tata showroom and buy Tata Punch, which is around 9 lakhs, 8 to 9 lakhs, that has level 2 plus. That has all these features that I was talking in the Lexus, right? So what has happened in this 11 years is traditionally all these advanced features for the, especially for the automotive, was developed by automotive companies. But something started changing from 2012 to 2015. One of the companies is Mobileye. Mobileye, how many of you have heard of Mobileye? So Mobileye is actually an Israeli-based company, and it's also an Intel company. So I'll take that example, but there might be other companies also. So what Mobileye did was it was actually started as a small startup, and they started developing these features like advanced driving features like lane assist, automatic emergency braking, automatic lane change, and all the almost all the autonomous driving. Currently, they are trying to have level 5. So we, as you know, autonomous driving are classified as up to 5 levels. Level 1 is very basic features. Maybe it might have automatic emergency braking. Level 2 will include, say, lane assist, lane change, and other things, right? And level 3 is slightly advanced. Level 5 is totally autonomous. Level 5 is where you don't need any human intervention. Like you can just sit back and relax. Automatically, the cars will drive you to the destination. Now, what this company did was it was a software company, it was not a traditional automotive company. They started developing these features, and I think one of the first customers was Tesla. So the initial Tesla vehicles had this autonomous driving from Mobileye. And slowly they gave to lot more companies. Today, Tata Motors, Mahindra, if you take Mahindra XUV, and if you see all these ADAS features, it has mobile in it. And what this company did was they actually brought down the cost of this all this advanced premium, super premium features that we were talking about, right? Only super rich could afford to use those kind of features. It's now available in the basic Tata Punch, which is a basic car starting from 8 lakhs, right? So if you now look at the history, in 10 years, we saw that the advanced feature that was available only for certain maybe like very minuscule super rich people. Even in the among the super rich, only certain people were able to afford. That is available to even a common man. Everybody who is able to afford a very basic car will be able to get this premium features. So what we are going to see is all the cost is drastically reduced. So now there are talks about a level 5. The level 5 is total autonomous driving, right? So then there's a concern. Already, I think our Minister for National Highways and Road Safety, there was a question posed to him in one of the interviews where he asked if a level 5 autonomous driving comes to India. Don't think that we might be kind of skeptical whether it might be able to drive in Indian driving conditions. For the XCV 7 that is available in Mahindra, the model was trained on the Indian's road conditions. So if it will not be surprised in another 5 years, you might start seeing at least level 4 or level 5 start getting deployed in India as well, right? So then a question was posed to this Minister for Roadways and Roadways and National Highways, whether getting level 5 autonomous driving will remove all the cab drivers' job. Probably that's a valid concern, right? If autonomous driving comes, then I know there's no need for any cab drivers. Then all these cab drivers will definitely lose their job. That's a valid concern. But what I would like to look is I would like to look at it from, so what the minister replied was he will never allow level 5 autonomous driving. Probably he didn't have the full context, so I'll not blame him. What I will say is this autonomous driving, if it comes, probably the government can bring in a regulation. Anybody who has certain income of, say, certain level, right? If they are in the below poverty level or whatever that income level that government want to decide, they can say only they can give a license to have only autonomous cabs. But that way they can restrict. So that a cab driver currently is spending like almost more than 10 hours driving and hardly earns a few thousands of rupees. We have never seen a cab driver driving the cab and living a pretty decent life, right? He's leading a life, definitely, but say this struggle. We all know that that's a fact, right? Nowhere, even if you take it in India or maybe in Singapore or US, cab drivers are not making a huge amount of money. They are making money to just to sustain themselves. So what I initially is, if a government regulation comes saying that only certain level of income people can own or get a license for cab driving, they can buy a cab, leave it for the daily use so that it can automatically earn money for him. While parallel, he can use his free time to work, do another job. Then his income can actually develop, right? So these are the advantages of how AI and technology advancements can actually help improve the people's life. So we don't always be worried that my job might be taken away, right? What I'm going to say is technology's evolution will always be beneficial. It will create newer types of jobs, newer types of roles that didn't never existed. Say before ChatGPT, there was never a role called prompt engineers. Today, if you go to Naukri or Monster.com, you'll start seeing that there's a new type of job called prompt engineers. They need prompt engineers because all these models that we are talking about, they need prompts to be given. You need to ask question, and you need to ask a question in a better way. Only when they give you the answers. So that way, new types of jobs will come. Cost of this technology will come down so that even common man will be able to access these technologies. And other impacts want to do is like that's where one of my focus area of today's talk is you and me have a very key role in all these things. These are huge amounts of right. We want to reduce this huge amount so that how you can actually bring down the cost so that more people can start using this cost. We'll do a talk about how we can do all those things in the future slides. Now, there's a huge models, 175 billion parameter models. There's like 1 trillion parameter models. So we saw the cost of this. And those models, like I said, had data from the beginning of human history till date. Now, if I take more enterprise use cases, right? Any enterprise, let's say we have a bank or if an investment advising company, right? They don't have any data from the beginning of human history till 2020. They don't need those kind of data to make an investment advice, right? They need data related to their marketing or market conditions, maybe 50 or 100 years of what of how the investment, let's say the big investment from, again, I will not be able to take the names. Let's say one big investment firm, this is actually a live example, a big investment firm used to uh, service customers, the high net worth individual, people who are having at least $8 million or above. Those kind of customers, if they used to go to this investment advisory firms and they seek their advice, right, for the investment. And generally, this investment advice will take around, say, 2 to 3 months for them to generate a report based on the risk taking capability, based on the preference and all those things, right? Now, what this company did was they actually took one of the smaller open source models, like say Llama to 7 billion parameter model. It's not a huge model when compared to ChatGPT. ChatGPT 4 currently is 1 trillion parameters, and they just took a 3 billion or 7 billion parameter model. They took all the 50 or 60 years of data that they had and they actually fine tuned. So before I get into fine tuning, how many of you are aware of what is fine tuning, RAG? Few hands. So for the benefit of others, I'll just talk a few seconds about what is fine tuning and RAG. So you have all these open source models, right? There are so many models available in the market. There are hundreds of models available in the market, and you might want to add your own data to it. There are actually two ways of adding your own data into the existing model. It's called fine tuning, and one more called RAG, retrieval augmented mechanism, right? There's a retrieval augmented generation. There's one more method. And this is fine tuning. Assume that you have a huge data. Let's say Intel wants to generate, want to have use a model in its own for its own purpose. So we can use fine tuning. I'll take 65 years of Intel's data. Maybe like if I take all the text documents that was generated within Intel in the 65 years, it might be like say a couple of gigabytes or maybe 1 terabyte. Take up the data and take some 30, 40 years prior research on semiconductors, manufacturing of silicons, fab, how do you build a fab and all this data. And you can, it's a one-time data, right? You are collecting huge one-time data. And then you are actually adding, you can inject that data into an existing model by using a process called fine tuning. So whenever you have huge data and it's a one-time process, it's not a something that changes on a day-to-day basis. You can use fine tuning, right? And it's a very fine tuning itself is also almost a very expensive affair. It's almost very comparable to cost terms. It's almost comparable to what you see with training, right? The amount of cost that is involved in training. Very similar kind of cost is also involved with fine tuning. Now, assume that there's a situation where you want to generate a model for, say, stock market predictions or stock market analysis and things like that. That's data that keeps changing every second or every, it's almost kind of a real-time data that keeps coming in. So in those kind of scenario, what we recommend or the recommended way is use RAG. Use RAG to pump in real-time context to the model so that the model understands what's the real-time current scenario and responds to your query based on the current scenario, right? I don't want a model to, if I ask what are the factors that are influencing Intel's stock today, I don't want the model to go to 2020 and pull out the factors. I want today, what happened 1 hour ago, I want the model to go back to the 1 hour news, take up all these factors that impacted Intel stock in this 1 hour and give me that answer, right? In this and this is a small amount of data, right? In terms of gigabyte or terabytes of data that we use to fine tune, this is a small amount of data. Use that small amount of data, use the RAG, pumping the real-time context to that this open source large language models, and it can start actually giving you better results, right? So that we now you hopefully understood what is fine tuning, what is RAG, and where do you want to use these things. Now there are majorly two different ways ways that you can actually implement this RAG on fine tuning. One is you don't have access to the model. Like for example, if you're using Azure services or OpenAI services, they'll give you an exposure on API. use that API, and then you can implement either a RAG or a fine tuning, right? You can do that. What the other better alternative for enterprises, what we recommend for most of our customers is use open source models. Like there are almost hundreds of open source models. Some of the popular are Llama 2. How many of you have heard of Llama 2? Bloom, Falcon, Mistral. So these are all different types of open source models for large language models, but there are models that can generate other type kind of things, right? Llama 2 and other things can generate text. You give a text prompt, it can give out a text for you. Then there is a stable diffusion model. You give a text, it can generate an image for you. And there are models that can generate, you give a text, it can generate a video, audio, and all this. Basically, it can generate any type of data for you. What we recommend is use a smaller large language models like Llama 2 or something, and then do a fine tuning or a database on that. And you could implement domain specific specific models for your use case. So, for example, I talked about the investment advisory firm. They can take a 7 billion parameter model. They can take a 60 years worth of investment advice and take a current scenario, current market scenario, do the RAG and fine tuning, develop a personalized finance chatbot. And what this company, like I said, the company actually implemented it on 300 of their financial advisors. They developed this platform and gave it to 300 financial advisors. Things that usually used to take months or at least couple of weeks to generate a report can be generated in for 5 minutes, in less than 5 minutes. The investment advisor will give a prompt, feed all the data to the model. It can generate a professional, very good investment advice in minutes. Things. So imagine the amount of time that is saved from weeks and months to where it's come down to 5 minutes. And the report that is generated, the quality of the report that is generated will be much better than the quality that would have been ideally been generated from the amount of time that a human would have to put. So then the question was whether they had almost around 12,000 investment advisors across the globe. Then they sack all these employees, maybe keep only few of them. No. So what happened was the total cost of this investment advice actually drastically reduced for them. Right? Instead of a high net worth individual being say I'm giving a rough estimate. I don't know the exact numbers. Let's say if the earlier fees was, let's say if it's 1%, right? 1% coming to let's say around 50,000 US dollars or at least 100,000 US dollars. Probably it can come down to less than 10,000 US dollars for a huge ticket investment. So that way, the overall cost of that is reduced. Now, people who are not only high net worth individuals, people who are also lesser, like who don't have so much of money, but they still want to invest. Even they can actually go and seek very good professional advice from these investment firms. So that way, what happened? It's again a very classical example related to the banking, right? Before the advent of computers, right? If you know, maybe in the entire Bangalore, there might be some 10 or 20 banks, right? Maybe like in each area, there might be only one bank working independently. Now, in each campus, maybe within this IISc campus itself, we might have 2 banks and 10 ATMs. What happened was when the introduction of computers, the total number of the earlier cry was computers will take away the banking jobs, but that didn't happen. Actually, initial computers made that we have more number of banks. That means more number of people. Today, if more number of people are employed in bank than what was employed in 1990 or before the introduction of computers, right? The same thing is happening here. Like the investment advice for firm will not reduce the total number of jobs. It will actually increase because more number of people will be able to be serviced. And the same thing will happen for the software industry also, right? All these coding models like Star Coder, Llama, Star Coder or Code Llama or other models that can actually generate code for you will not remove the jobs. It will actually reduce the overall cost of the producing a quality software that can actually impact get even a small kirana shop if he wants to develop a website. Today, even if you go to the cheapest surf shop where to develop a website, it might cost you around 20,000 rupees. I'm giving a reference. That's one of the cheapest with a decent website you can get in India, in Bangalore, right? But if I can use this any of these coding models, I am the Kirana shop where I can come and say that I need a website with 5 pages, and these are all my data. I feed this data into these um, models, and the model can generate me this entire 5 pages of website in another in 5 minutes. And there's also models which can generate images for you, right? It generate brand new images. I mean, currently, if you see most of the websites will be using copyrighted images. We go to a website web designer and ask him to design a website. We might take some copyrighted images, put that a flashy image, and if your website is not popular, nobody will see. If your website is very popular, somebody will come and sue you that you have used a copyrighted image, right? But you can use a model like Stable Diffusion to generate a brand new image that is unique to you, right? And the cost of that is hardly few seconds. You give a prompt in 2 seconds, you get a brand new image that is very specific to you. That way, the cost of that, the cost, say for example, the website used to take earlier 1 week for a web designing company to develop. This I'm talking about the grassroots level for a very simple use case, right? Now, this the same website can be developed by the company by in 5 minutes. You'll generate the entire 5 pages. Maybe you might spend 1 or 2 hours to clean up. Currently, you might need some cleanup, but at the rate at this what this generative AI models are evolving, even that is also not required, right? So you generate these images. So hardly even if you take lowest billing hours for a software engineer or for a web designer, right? Let's say his billing hours is 1,000 rupees per hour. It's almost like for less than 1,000 rupees, you are able to design this entire website. And now maybe all the kirana shops and other things, they can also have their own websites. So that way, the overall demand for software services will increase. So what I foresee is when this will not have any huge impact, it will have an impact for people who are lazy. People who are stuck to one particular technique, probably they learned something in their college days and they are stuck to that, probably it might have an impact. People who are always evolving, always learning new things, they will always find relevance because they are always relevant. They can always also compete. So this is actually a competition for us, right? These are all competition for us. So if I have to compete with it, I need to have better knowledge. I need to know how this model works, how these things are working in the background, so that I can play around with it and make sure that we dance to my tunes, right? So I will recommend it's good to see that you are all working professionals enrolled into this course and learn all these new things. I think you are all on the right track. Keep continuing this journey. Don't stop it here. Keep learning new things because the competition is huge in terms of non-human competition, and these models are very powerful. I recommend go back after this workshop, try out this some of these models and see how powerful they are. Right, even a 20 or a 40 years experienced guy will not be able to compete with them because that's the kind of intelligence that is embedded inside them. Now, I said we can take up a smaller models and do all this fine tuning, and it's also we need to keep upskilling ourselves. What are some of this upskilling that we should be doing, right? We should not. I think today in this course certification, I think you all learned how to do program, how to develop a model, how to play around with a model, how to train a model, all these things I learned. So that's just the beginning. Keep learning. One of the other things that I want always you all to learn is how do you optimize this entire process, right? When you say the deployment costs around $40 million for an inferencing, even if I am able to, let's say, when you put a prompt in ChatGPT, it takes around roughly minimum of at least 3 to 5 seconds for the prompt to come out. If for every request, if it's taking 3 to 5 seconds, if I can optimize it and if I can reduce even 1 second, and assuming there are more than 300 million active users for ChatGPT, the amount of savings that you do in terms of overall cost of compute resources required, the overall cost of power, and all the things will be drastically reduced. So, how do you do that? For that, uh, you need to start learning not only about how to build a model, you also need to learn about the hardware features, right? So today's hardware, if you take a CPU, for example, if you take the Xeon Sapphire Rapids 4th generation CPU, it's not a very common CPU with only cores in it. They also have advanced accelerators in it. We'll go into those accelerators later in the slide. Where you need to do some, I saw your course, this thing, right? Course content. I think you've gone through Python, went through Pandas, you learned Pandas, NumPy, and then you went through all these various AI training model frameworks and algorithms, things like that. So I'll take an example of Pandas. If you take Pandas and if you try to pass some CSV file, let's say there's an example of let's say you are given a 2 GB file, right? You are given a 2 GB CSV file. And since you are all learned Pandas now, if I give you a Xeon, let's say I give an access to a Xeon based server to all of you, which has around 56 cores. And if I ask you to develop, pass that CSV file, you take that Pandas, you'll write a simple 10 lines of code. You can actually read through that 2 GB file. The 2 GB file on Xeon almost takes around 300 plus seconds, 300 plus seconds to process it. Now, what companies like silicon manufacturers like Intel and others are doing is they are also including a lot of accelerators, specific dedicated silicon circuit that is different from cores, right? There's an accelerator in Xeon called advanced matrix extension. What this does is it actually enhances your mathematical computations, right? Now, for the example of Pandas, I said Pandas is inherently not core friendly. That means we are having 56 cores on a Xeon. Now, if you are a normal generic developer, let's assume that you are a normal generic developer who just learned Pandas and you are happy with that. That means you are using, you write a code, it takes 300 seconds to process that CSV file. And when you see the hardware utilization, go to that, you use a LSCPU or any of the hardware utilization tools, and you see that there's only one core which is being used at 99%. All the other 55 cores are lying like that. Your company has invested on that hardware. You are taking 300 seconds. That means 300 seconds worth of CPU compute time as well as the power is being consumed. And overall experience for the end user is also impacted. He has to wait for 300 seconds to get that output. Now, what Intel did was Intel picked all these open source frameworks like the Pandas, and they modified it a little bit. And we have an alternative for Pandas called Modin. What this Modin does is you don't have to change any of your code. Usually, you write like import Pandas as PD. This is the statement that you might be writing. What the only change that you have to do is import modin.pandas as PD. That's the only change. The word just modin, that's the only additional word that you are going to add. Once you add it and if you re-exhibit your code, suddenly you see that your pandas is using all the 56 cores and instead of taking 300 plus seconds, it's taking only 30 seconds. Right? So that's the impact. So how did you know that? For that, you need to actually know what's the hardware features. So don't go only with the open sources. Open source is just the beginning that you are aware now. These are all the frameworks. These are the tools that are aware. But also go beyond see how to optimize because the kind of compute requirements for this kind of use cases is huge. Even a small, you as a developer, the only effort that you put was just adding one word called modin dot. And the impact for the end user was it reduced his waiting time almost 10x from 300 seconds to almost drop to 30 seconds. That's the impact that the end user is having. For the company, instead of having, say, 10 Xeon servers servicing 10 customers, we can have one Xeon server that can service 100 customers now, right? In a better fashion than what used to happen earlier. So overall cost for the companies has reduced. The overall cost for user experience for the end user who is actually using the product, for him it is better. The only effort you and me put was we learned something new that we should add a word called modin dot instead of just pandas as PD, just modin dot to pandas as PD. So this will actually have a better future. It'll actually, these are some of the skills probably the companies are also looking, right? How do you actually optimize? How do you go beyond the generic trend that you see in the market, right? You should always go beyond that. So learn to, I'll show you some of the future slides where you will have learn what are some of the special hardware features. Don't just learn about software, learn what is the underlying hardware and what are the special features available in the hardware and how to utilize these additional features that are available in the hardware, especially for generative AI. For a normal use case, probably might not have to worry so much because the compute resources requirement is not much. But if you are able to do it, it's well and good. But generally, for generative AI cases, we have to determine that's even the small effort that you put will have a huge impact at the bottom lines of a lot of companies for the user experience. So coming here, coming back, right? Like I said, you develop, you take up the smaller models, implement fine tuning and drag, and develop models that are specific to your industry. Don't you take a huge chat GPT and deploy it and have a huge cost. Instead, take a smaller model, fine tune it to your specific industry. Let's say for management itself, if they have this entire course, they can take a small Llama 7 billion parameter model. They can dump their entire course material and whatever materials that they have into that model. And they can use this model actually to better service their customers, right? To better service students like you, right? So they can provide a better teacher assistant or a student study buddy or a parent chatbot portal and all stuff. Definitely these are all very basic examples that are flashed here, but a lot of we'll also talk about some of the other examples from the industry perspective. So any questions so far?
One thing, yeah, so one thing I feel, sir, like probably from a risk perspective, right? Now, what I see, like from industry perspective, also some triple E person also now started coding because Chat GPT is able to provide them all the things needed. And you rightly said, like the juniors, right? Who are like 5 years or 10 years, they have a lot of challenges because in college only people learn to use these latest tools. And they are kind of coming up and they are kind of just beating the 3 or 5 years old easily. Yes. Luckily, we are old enough to cross the bridge. And we have other things to, management and other things, right? From a bigger decisions, right? And also from other domains also, right? Whatever you have called out here, right? The expertise knowledge are fading away because you introduce at low level, everything is done. There was one doctor talking about this diagnosis thing where they were trying to say that if you are not constantly reading the report, you will lose that mental ability to do that. Like no calculator remover.
Yes, yes, yes.
So how you take this? I know like you're talking about more about opportunity, but also how you are trying to message the society, how they have to kind of model themselves to adjust to these things.
Yeah, so that's a very good question. The question here is how this risks or the challenges were posed. How do we want to take it? Should we take it as a blessing? Should we be worried about it? I would say these are all kind of challenges that will bring in new opportunities. Any technology revolution, for some people it will be a threat. For majority, it will be beneficial, right? Like I said about the banking industry, they are using the computers or the autonomous driving. For some, it is a threat. For some, it also depends on how you actually look at that technology. The technology, you need to be able to use that technology. So one thing is we need to constantly keep getting updated for ourselves, right? You need to attend this kind of courses. You need to keep reading things, especially skilled workers like us. We cannot be lazy enough that I learn something and I'll stay with that forever. That probably that kind of scenario is having a huge threat now. You cannot be idle anymore. You need to constantly keep getting updated so that you know how to handle this kind of situations, right? These are all the move. This is actually bringing in a lot of new opportunities for you and me, right? We need to utilize those opportunities. We need to add more value to what we bring to the table, right? Companies hire us because we bring more value to the company, right? We need to keep updating ourselves. So I will say I will try to look it in the positive way, right? Because bringing newer opportunities for us, so keep constantly updating. It's definitely we need to put in hard work. A lot of hard work. People who are doing a lot of hard work definitely it has to be in this industry. So definitely it's opportunity. I'll see it more like from an opportunity. Don't be scared that this kind things can remove certain things. Don't be scared of the technological evolution. Always technology evolution poses challenges. We need to adapt to that emerging scenario and try to be more relevant in the market. Yeah.
Let's say I want to start one startup.
Sure.
And I don't have any funding also. And then also, I don't have product idea. So what should be the, the startup person mindset, like to complete this journey from, I don't have funding also, and then I need to pay the employee hiring, employee, everything I need to do.
Yeah.
So can you provide your perspective?
So from the startup perspective, right? So from a startup perspective, funding is actually one of the least concerns, right? What I have seen through my experience, funding is not a big concern that we need to be worried about from a startup perspective. Funding will find its way. There is actually a huge amount of money floating in the market to find potential ideas that can be invested. So don't worry about funding when you're actually thinking from a startup perspective. Think about your ideas. You said you also don't have clarity on the ideas. So how can I use Generative? Well, Generative can be used to refine your idea. At least you have a very basic idea. Okay, I want to get into this specific industry, right? Then you can use these Generative models to refine your ideas, gain more, because this model knows huge all these entire startup ecosystems, all the data that is available in the open source, in the open, right? You can query them and refine that ideas and then work on it. And definitely, from the perspective of funding is definitely from my own personal experience, I see that funding is not at all an issue for a right guy. The huge amount of funding we are seeing, right? If we have a very good idea, say Byju, so it just started as a very small learning center in a small room in Kormangla. Yeah, they got multi-billion dollars of funding. I mean, that's so funding is never an issue. So don't worry about funding. You focus on your core item, core work. The funding, money will always follow you. Don't try to follow worry about the money perspective. So generally, you should be using all these generative AI models to help you augment, right? Definitely, we humans have certain limitations in terms of amount of data that we can gather. Even if I have data, it might not come out at the right moment of time, right? So generative AI models like this can definitely help you refine those ideas, can iterate to this. We can actually ask let's say you have an example to develop say learning portal or autonomous learning portal or something like that. We can ask the generative AI models, how can I develop this? Can you develop me a prototype? What are the challenges in the posed by this post in developing this idea? Can give you certain recommendation. Maybe today's stage, it might not be 100% relevant because some of these kind of decisions are made in a private conversation. All the open source public conversation that you might have will not have this kind of decision making criteria readily available. And don't worry if your ideas, don't worry about the success or failure of your ideas. Ensure you do a good research whether you have a good market for that idea. Technology is one thing, right? You should technology is not the only skill required for marketing. That's kind of one of the last skills probably might be you should be looking at. Apart from technology, you should also know how to get into the market, right? You need to know your customers. If you're knowing your customer better, then definitely technology, money, and everything will actually can follow you, right?
Sir, as an analyst, I started my career with learning softwares only, so did not much learn about hardware. But nowadays we are slow. And in my early days, when I remember I was in fourth standard, it was only Intel Pentium and only Intel, which was ruling. Then slowly came dual core, Core to Duo, and so on. Now we are in i9, but slowly Intel has been defeated by NVIDIA, and we are hearing more about GPUs than that of CPUs, right?
Yeah.
And even with respect to mining Bitcoin, even the GPU stable diffusion. I mean, we are hearing more and more of GPU. Can you just elaborate how did the CPU got? How are we giving more attention to GPU? How did we get to this phase?
Sure.
With generative AI.
Sure. So that's a very good question. We as software, in fact, you are not aware, even I was not aware of the hardware details until I joined Intel, right? Until I joined Intel, I was in the same boat as you, learning only about software, being happy with software, don't really get into the hardware because I thought, okay, all CPs are same, right? Only this might have 4 cores, that might have 50 cores. That's the only difference that I thought was in the actual hardware, but that's not the scenario, right? So we need to learn, like I said, I'll get into details of the hardware, like how do you actually, what are the things that you need to look from a software developer's perspective. From your other question, right? How did the GPU got more relevance into this entire generative AI things? So Intel's definitely is having a challenge, right, in terms of the competing in this generative AI space. But the Intel definitely is doing playing a very big role. In fact, just in this 2 years, we have deployed three supercomputers. One is Aragon National Laboratories in US, was completely done on Intel Xeons and Intel GPUs. Intel that has GPUs, but not for the small consumer grade GPUs. It's mostly on the data centers grade CPUs, GPUs, right? So we deployed the Aragon National Laboratories. Then there's Cambridge University. Just last September, they deployed a supercomputer, and even the LRG in Germany. LRG is a research from research government-funded research center like IISc in Germany. Even we deployed a supercomputer based on the Intel. So from that perspective, definitely we have challenges. I'm not denying that we don't have challenges. We have challenges, but to a specific question, why GPUs matter in all this generative AI space, right? You take the model. Till now, what we were doing is we were taking the model as a software engineer, maybe write a Python code, few lines of Python code, call an inference, give a prompt, give a response. But when you actually look at the final object code that is getting executed, right? It's all about matrix multiplication that's happening. Almost 90% of the calculations that happens when you put the prompt for all these generative models is all matrix multiplication. I'll give you an example. Let's say I'll give you a sentence, right? I'll give you a word I. I'll say the word I. Now I want to predict what is the next word that can come after I. Tell me any word that it can come after I.
Is, I guess.
I is okay. Can you tell one word after I? Am is one word. Can you tell one word?
Want.
Want. So we already have three options, right? I started with I, right? One is am, want, right? Now, if you try to look at the way how it actually works, right? All this large language, when you feed all this data into this, let's say we can use tons of documents and feeding into the large language model. Large language models try to relate what is the probability of the next word after the word I, what is the next, even if in ChatGPT, right? If you give a prompt, you have seen that it doesn't give you the answer in one shot, right? It doesn't give it gives you word by word. You see, it comes word by, just notice it, probably if you have noticed it, next time, it gives you word by word. So you started with the word I, and now trying to predict what is the next word. So let's say 10 people voted for the word is, so it will give you a rank 1 here. For this one, it might give you a rank 2. And let's say this one is rank 3. And this is a very simplest way I can explain how this matrix is built internally. Now, the model will actually try to build matrices. So, build one model. This one, right? Now, what it do is, let's say it choose is as the next word. It will say I is. And then what's the next word it want to predict? Then it keeps this, it builds matrix upon matrix, and finally at the end of it, it's all matrix multiplication. When we were learning all this matrix multiplication in engineering, I was wondering why the hell we want to learn all this matrix multiplication? Where are we going to use it? So when you're actually building a model, you have to be aware that's how it's actually going to, all these calculations are happening. And GPUs, if you know, GPUs are meant to do mathematical calculations. When GPUs were introduced for games, all the games again involved GPUs were when the late 90s were introduced specifically for the gaming industry and for graphics, like say the video editing or the animation, things like that. All those things actually involved matrix. At the end of the day, at the silicon level, it's all about matrix multiplication, and they were very good at matrix multiplications. CPUs are not meant only for matrix multiplication. They can do many other things, right? It's a general silicon. It can do anything that you want, right? It can do matrix multiplication. It can do string concatenation. It can do streaming. You program it. You can do whatever you want with it. But GPUs are really good at the matrix multiplication, and that's when all this time, I think till 1965 when Intel was founded till that 2020, we had a golden period because CPU was more relevant. So we were happy with the CPUs. We had data center GPUs there. We were also happy. And NVIDIA, to be frank, NVIDIA also had its own struggle, right? From late 1990 when it was NVIDIA was founded till that ChatGPT's time frame. NVIDIA is also a struggling company. They have a fair amount of challenges, right? Every company goes through that. Whenever a new technology comes from, for some it will be a huge opportunity, for some others it will be a challenge. But definitely, Intel has new products that are coming up. I'll show you in the slides where you see better opportunities. So to answer your specific question, why GPUs were relevant? Because GPUs are really good in mathematical calculation. Especially for NVIDIA they had that CUDA framework that was already good at doing all this. You can actually do inferencing with models very easily with that CUDA framework. And people and OpenAI was one of the first customer who actually started using this NVIDIA stack, and then that became the norm. But what I would like to say, that's not really the norm. There are other different options. Probably we'll go through the other different options and see how we can use other hardware, reduce the overall cost, reduce the overall impact of things like that. Okay,
So, as you said, right, this RAG and this thing can be used, right, in database, right?
Can keep the mic a little closer.
Yeah. So basically, how do you validate the output generated by GenAI model? Let's say if I give some this RAG and database, like we are doing some localized search, right? You are saying use some model, right? And then you do these companies might put their own data, right? And then that model actually learns that data and give the output.
Yeah.
How do I validate that result is correct or not with the actual data? Let's say I am doing some analytics, right?
Yeah.
And I'm asking for the average house price, and it gives me some. How do I validate whether actually that it's getting it is correct with the actual data is present in the database?
So this is a very important question, right? How do I validate the answers that are coming out of these models? How do I validate? That's where the human's role will come. That's where our experience will come, right? At least to begin with, until this model is mature enough that we have the level of confidence that we need. We need the human intervention to validate those things. And what I will again tie up your question to this specific thing that we are discussing. Use a smaller model. Use the data set that already you have, like for example, like I said about for Intel, I can take the 65 years worth of data from Intel, all the silicon, like how did we design a CPU, how did we design a GPU, how did we construct a fab, and how did we actually develop a software, how did we optimize, and how did we make all this business. And let's say we have take all the Intel's top secret, the documents that is available with Intel, and train it in and use it for internally, right? Then the model will actually build all kind of relationship within this within the documents that we are supplied. And most likely it will give you relevant information, right? It will give you an answer that is mostly in line with your expectation. But definitely there are chances where it might be off the track, at least to begin with. At least still in the evolution stage where you might not have 100% confidence. There's a term called hallucination in generative AI. That's very common. That's something that you also need to be aware. You try to ask an impossible event or some kind of an imaginary question to ChatGPT. It will not say that I don't know. It will hallucinate. It will have, this is a very industry specific term, specific for generative AI models. It will hallucinate and start generating answers for the imaginary question that you give. So there is a chance that your model can hallucinate in certain scenarios. That's where humans experience will come. Probably we need to have when you're actually building a generative AI pipeline. There's also one of the models between the inferencing and the end customer is there's a pipeline called prevent hallucination. Like you can actually have a site module that can check whether there is any hallucination done by these models, right? And then to prevent the filter. One of the filters that ChatGPT uses is like offensive languages. Probably if you're trying to ask any offensive questions or any sensitive questions, probably it will try to be more generic because the model doesn't have an answer, but the filter will filter it and then give the answers to it. So definitely humans intervention, at least to begin with, for at least for the next couple of years is required. But once these models all this matures, they will definitely be acting more independent. In fact, I suspect many of those models are already there in the labs, which are like super intelligent, which can think on its own, right? We already see all these big people telling the governments to take do the regulation. India already, the government of India, US, and others are trying to get regulations for the controlling AI. Because some of the AI models that are generated in these labs are like super intelligent that can make a fictional movie into reality. Probably I was probably I don't know how many would have seen a movie called I Robot. It was I think some 15 years old movie where a robot becomes super intelligent and tries to dominate. At that point in time, probably it was a fiction. Probably that fiction is now a reality, at least in the labs, and people want to. At least people are all the people who are aware of these things will keep constantly telling the governments to regulate all this AI so that this misuse can be prevented, right? So that's when all the experience, additional skills, human interventions is required.
So do you see these large language models getting consolidated, similar to what we have seen in terms of search, right? For example, earlier on we had at least like they were able to democratize the search earlier on when the technology was very new, but eventually it was consolidated and we have Google as a major search engine. So similar in the
So there was that's a very valid and important question again, right? There was a very valid concern among the bigger technology enterprises like Facebook and others. Only OpenAI is able to garner all this data from all these users. In fact, the data that we are actually prompting into Open ChatGPT and other things are being reused for training, and their model keeps intelligent because you are all using the daily feeding the data into it, right? So that way, what's happening is one company is now giving so much of inputs from millions of users that their model is becoming super intelligent, right? How do we democratize it? That's a very valid question, important question that we also have to be worried, right? And that's when few enterprises like Facebook and others started seriously thinking about it. Now, we don't want one company to be having a model that is like super intelligent and they can start dictating terms to others, right? And that's where the whole concept of this open source models. If you see in certain interviews from Mark Zuckerberg and others, what is their motivation to open source these models is exactly this, to answer this exact concern. They don't want one company to be the monopoly on the AI space. They want these models to be open source so that you and me, a common man like you and me, can actually with a smaller hardware, we can actually generate our own models and utilize it for our own better. That way, we can democratize. We can have models. Not one company is controlling. Many people. There are many players there. I think Llama 3 is now already in the market. Llama 3 is around, I think, 400 billion parameters or something. So all these models are open source that even we can freely download and play around with it. And definitely, luckily, at least in the generative AI space, a lot of democratization is happening. That's a good thing. And I recommend maybe you should stop using ChatGPT and develop your own tools and start developing, working on the open source models. ChatGPT only for an emergency and things like that you could use, but for other things you should be start working on your own model. Especially if you're trying to use in your enterprise use case, right? Don't use ChatGPT. Use your own models.
You're using open source. So especially when you're using open source models, or there's this risk of like since these are trained on copyrighted material and infringement and suits, etc. So as a person using that in company, how do you, manage that risk?
Yeah. So this is also again a question that all the enterprises are worried. Today, if I can show a demo there. If I go to ChatGPT on my Intel laptop, there's a warning automatically comes up. Be sure you are not inputting any of your key Intel top secret related questions, things like that. In fact, there was an incident. I don't remember the company. It was a major semiconductor company where the employees started using ChatGPT freely, and they started posing questions related to their IP and things like that to ChatGPT. And when the ChatGPT 4 came up, ChatGPT guys, the OpenAI from, they actually use that data to train that newer model. And some guy actually prompted the frame the prompt such a way that he was able to extract the IP out of that ChatGPT model. Now the IP, which is very top secret in a company, become an open secret with the ChatGPT. So it's a very good question, and I can just quickly show. If I go to ChatGPT in my laptop, right, I see that there's a warning that comes up. So enterprises, they're definitely working on this. So that concern is the biggest concern that enterprises have, and some of the enterprises actually stop blocking the usage of this publicly available services as well, right? Like they start blocking it. I think usually I get a warning. They're saying that you cannot use ChatGPT, or be aware that you are using a public thing, not to input any into top secret documents, things like that. Yeah, that's a concern that you all also have to be worried. If you are an company founder, if you are managing your own startup, or if you are decision makers, do ensure you introduce this kind of checkpoints in your organization, so that employees inadvertently, we are kind of getting addicted to ChatGPT. In fact, I'm also kind of addicted to ChatGPT. Most of the emails response probably my ChatGPT itself is writing. That's where also sensitive. I might sometimes take a sensitive email and dump it in ChatGPT and ask for a response. At least I'm now aware I'll not do that. But you also be aware there's a potential that your employees can do that. And if you're a small startup, probably you should be protective of your IPs, right? Definitely, ChatGPT will increase your productivity and give you better answers. That's actually a temptation for many to use it. Don't use it in your enterprise scenario. Be wary of using it. Good. Any more questions before we proceed?
How we can avoid in most of the cases hallucination?
So, sorry, can you please come again?
How we can avoid hallucination?
How we can avoid?
Hallucination, model hallucination.
How we can hallucination? Probably again we need to develop a separate algorithm for that, right? One thing is, like I said, manual human intervention is required, especially for sensitive use cases. If you are handling is, let's say you are handling an use case related to some kind of a medical and healthcare industry, or maybe even you are developing a study platform, and at least to begin with, manual human intervention is required to ensure that hallucination beyond, like you, for example, if you are working on the medical industry, if it's trying to give you advice related to certain things, it should be within that bounds that you are defining. So we need to definitely add a filter, and there are techniques to work on this algorithm. It's a separate algorithm that you need to implement in your pipeline, so that you filter the results before it goes out. There's no like one defined way that we can prevent hallucination for all the use cases that we are taking. Depending on the use cases, you need to bring in those the subject matter expert and work with him to ensure that the answers that are coming in. One of the way, if you see, ChatGPT also works trying to improve their algorithm, is at the bottom for every response there's a thumbs up, thumbs down. Every time you thumbs up, that means it's supported, that means it's relevant. And every time you download it, that means kind of taking just a kind of an hallucination. Probably next time ChatGPT will prevent answering in those lines. Any one more question?
Hello.
Yeah.
Okay. See, the crypto is always expensive in terms of and G, like what we have covered. And recently, I was kinds of That's what it does, right? So I guess the environment is like we are doing it. In the past, two research institutes used to do this kind of generation, and they used to do a lot of compute. Everyone has this, right? So with GPUs coming in, everyone doing this. Now, what are the measures that see? One is yes, the information is very important, and we want to have an easy life. But again, this will result in more and more on the environmental side. Is there any qualities or someone who is doing chores? How do we optimize this? It's already some files which are already built. Can someone use it? Reduce the compute, or everyone start building their own? Then there is no end to this, right? So, what is the measures? Is there anything that is happening?
So that's again a valid concern that many people are also worried, right? Many industries are worried. What is the total carbon output for a particular operations or like training or inferencing operation that you're doing? It's actually there's an international forum that actually measures the total carbon footprint. There are also specific tools to measure the total carbon footprint for your training exercise for the inferencing exercise. In fact, this is one of the criteria for deciding which models to use, especially if it is going to be used on a very large scale. Assume that if you're going to deploy for say 1 million or more number of users, definitely this is one of the deciding criteria which models to use and whether you have done all the optimization. That's when this criteria become important, right? You don't want to use a big model that consumes a lot of compute resource and still gives a relevant answer and have huge carbon footprint. Carbon when measuring carbon, there are tools. Probably I'll share my contact details if you have specific detail requirement to measure carbon. And there are tools specifically available to measure carbon footprint. And you have to do it, especially when you're working on a large scale deployment. Measure the total carbon footprint of your entire hardware and software. It involves both the optimization from hardware and software, right? Hardware does some optimization, and software, like I said, the model example, right? From 300 seconds down to 30 seconds, you are reducing your carbon footprint in multi-scale. So you have to be worried. Definitely, the enterprises are worried. Tools are available, and I think one of the slide also covers what is the total power consumptions of different scenarios. So I'll cover that. So from my own perspective, from Intel's perspective, what we have is we have tools right from the hardware level. On the hardware level, we have say CPUs that most of you are aware, like we already been using Intel Core series of CPUs. On the server side, we have the Xeon side of CPU GPUs. On the client side GPUs, we have Arc series of CPU GPUs. And then just last month, Intel released a new processor called Intel Core Series Ultra. The Ultra is very something that you need to know about. The core series with Ultra has a specific accelerator within it called neural processing unit. What this neural processing unit will do is all your AI computations like that you have, it will be running on the neural processing unit instead of running on the core, and it will improve the efficiency, both power efficiency as well as the total time taken for inference and other things. So definitely, if you are wanting to develop things on locally on your laptop, try to get a core ultra series of processor, and you have to have changes. Not only that, you get an ultra series processor, suddenly all your code will run on NPM. It doesn't work that way. You need to maybe use the direct ML from Microsoft or ONX from Microsoft. We have also OpenWindow from Intel. Use these additional tools to use that accelerator. If you don't use additional tools, whatever is available in the open market, if you use it, only your code will be used, and you have bought a use powerful machine, but you're not actually utilizing those capabilities. And then for the deep learning applications, we also have a dedicated accelerator called Gaudi. The bottom that you can see, there's a dedicated accelerator for Gaudi. We do that. So from the software perspective, Intel has been one thing. What Intel does different from the competition is Intel wants to have an open architecture. If you see CUDA or any other frameworks, so CUDA is very specific. If you have written a CUDA code, it can run only on NVIDIA. It cannot run on anything else. It cannot go beyond NVIDIA's hardware stack. But what Intel and some of the other silicon vendors are also doing is they're trying to work with an open architecture. There's an open specification called One API. It's an open industry specification. Anything that any AI workload or HPC workload that we develop using One API is guaranteed to run on CPU, GPU, FPGA, and both Intel and as well as computing hardware, including NVIDIA. It can, if you're developing using an API, it can run on Intel as well as run on NVIDIA as well as on AMD or both the CPU, GPU, and FPGA as well, right? So I recommend that you all start using one API instead of being tied to a specific hardware vendor. So from the perspective of different types of process, right? Training, fine tuning, deployment. Intel has been working with all these different open source frameworks and libraries. I think was part of your course, you would have learned Pandas. I think XGBoost also was part of your course. PyTorch, TensorFlow. I saw even NumPy was part of your course and Scikit-learn. So what Intel's engineering team has been doing is Intel's engineering team has been working with all these open frameworks and trying to introduce optimizations. Like the optimization I told about Pandas, there's a modular framework. What Modin does is suddenly it starts using all your entire course and you can drastically improve the performance, reduce the total carbon footprint and power consumption, give a better experience to the user. And all these are open source tools that are available from Intel. Do use it. Don't always be the open source tools to begin with, but also try to see where are the different optimizations available. Use the optimized versions of this library so that the impact, the experience is improved. So from the architecture perspective, like I said, we have AIPC, that is the Core Ultra series of processors that can fasten up on the development of training or not training, mostly inferencing or maybe fine tuning it can do now on your local laptop or desktops. And then on the data centers, definitely we have Xeon's CPUs and data center Max and the Flex series of data center GPUs and the Gaudi AI accelerators. So from the recommendation perspective, right, you might have different scenarios and you might be thinking what is the hardware that you might want to use, right? Let's assume that you are working locally on your laptop, you are downloading some open source model and it's less than a billion parameter model and you want to do some kind of an end inferencing, right? You want to do an inference and get a reasonably response in a reasonably good amount of time. So Intel recommends use, if you are having 1 billion parameter model or less, use the core series of the Core Ultra series of processors and get a good response. It doesn't mean the Core Ultra cannot run a 7 billion parameter. It can definitely run a 7 billion parameter model on it, but maybe the inference time might be slightly higher than your comfort level. And if you have up to 20 billion parameter models and if you want to do basic inferencing, you can use a single socket Xeon. You use a one Xeon with one single socket, and you can use that for up to 20 billion parameters model. And if you want to do fine tuning or inference of up to 100 billion parameter model, we recommend using multi-socket Xeons or multi-socket GPUs. Like you might have in one machine, you might have 2 or 3 Xeon CPUs or 2 or 3 GPUs. You could use that. If you have 100 billion plus parameter model and you want to do reasonably good inference, it can be deployed to large scale users like 1 million users or more than 1 million users. Use multi-node deployment per racket. Nodes, like one node usually has up to 8 GPUs or 8 Gaudi accelerators. And you should use multiple such nodes if you're dealing with 100 billion plus parameter models for inferencing. And if you're trying to build your own models, right? There are companies where, especially in India, there are a lot of startups who are building their own models for Indian languages. Or if you are aware, like all the current models that are currently available in the market is mostly English based. Right, and definitely there's a huge market for Indian languages like Kannada, Tamil, Malayalam, Hindi. We can actually develop. There are actually the government of India is also working on a project called Bhashini. Bhashini is a project from government of India working on trying to develop models for Indian languages, and then there are multiple startups who are also working on developing the models. And that's a huge opportunity. There's also one of the emerging startup ideas to develop models and an end-to-end solution for an Indian language. There's a huge market for an Indian. Since these models can behave like humans, right? There's actually a solution from Renault called Deep Brains. And what Deep Brains does is it actually can render almost a realistic human and at the back end it's connected to one of the large language models. It can generate an answer, and the answer will be delivered instead of delivering it as a text prompt. It will be delivered as a human interface. Like you can have, instead of having a customer service talking to chatting with somebody, you can actually go to a customer service kiosk and actually start interacting with, as if you are interacting with the human. Search for Lenovo Deep Brain Pro. You can just look at it. It looks very realistic. Looks very realistic like a human. Actually, that entire human is generated by AI. And different, that's also a huge opportunity for startups if you're looking for develop Indian languages or maybe non-English language, not only Indian languages, like take any of the European languages or other Asian languages. I would say huge market there. This all this data that is there in English probably can translate to Indian languages and get it fine-tuned, so that even a person who is not specifically aware of English probably can use this models, gain knowledge from these things. Currently, I think even though we are all using it, we are still minuscule in India who's actually using ChatGPT, because others are kind of restricted because they're not able to interact with these models effectively in their own languages. So it's a huge opportunity there. Definitely, training is something that is happening on a large scale in India as well. There's a question.
Yeah, so in my organization, I have some of the hardwares in
Yeah.
So actually, if I want to play around in our lab, correct? So from the qualification point of view, let's say I want to build Llama or any other open source model. So do I need to change the specs like output codes or something like that? Or
So you don't have to actually change any of the those kind of things, right? Those are mostly done for gaming and things like that. What the code changes you do mostly on the code level, that two or three lines of code change that you will do. Like for Pandas, I said it was one change. For PyTorch, if you're using PyTorch, let's say you're using PyTorch to do training, computing, or inferencing, you will add just two lines of code to import Intel's extension for PyTorch. Along with the standard PyTorch that is available, you will actually import the Intel extension for PyTorch. And suddenly you will see that the Intel extension of PyTorch will be in the Xeon software Sapphire Epics that you talked about. There's an accelerator called ANX, Advanced Matrix Extension. So instead of utilizing the course, it will start utilizing the Advanced Matrix Extension to do all the mathematical calculations, and you see suddenly performance at least a 2x improvement in performance.
And if I want to understand, like, let's say on Intel website, somewhere I can go and just like with my model, correct, of a CPU. If I want to do certain things and run these models for the generative AI, so do they have a kind of step-wise procedure?
Yes, I'll cover that. We have something called Intel Developer Cloud. In fact, one of the earliest students, Devasis, who was part of the earlier program, he actually used Intel Developer Cloud to experiment this kind of scenarios on some of the latest Intel hardware. I'll give you access. I'll show you later. And if there's a shared instance that is available for free, but if you need dedicated instance, and if I can give you some credits, I can call and show you my contact details. You can approach me. I can give you the credits, some additional credits, so that you can use dedicated instance to evaluate. Maybe on the fifth gen is available on the developer cloud. You can use that to evaluate your scenarios.
Okay, that's the
Emerald Rapids.
Yes. Okay. Yeah. Okay. Thank you.
So summarize, others are available for yeah, sorry.
Actually, all these Intel platforms, actually, there is one serious, this from next side, there is a serious competition from this N1 and 2 chips. So how does it, will this Intel kind of software work on that N1 platforms will support?
N1 and 2, I haven't, I'm not sure about that. But it should work, I think. At least I have seen some people working on the PyTorch, and it has it should work. Probably I'll get back to you with the answer for M1 and M2.
Okay, thanks.
But ideally, it should work because it's an open standard. But I'm not guaranteeing you the performance, whether the performance will be on par with what your expectations are.
Sure. Okay.
Yeah.
Thanks.
Yeah. So summarize, we have different hardwares, right from the client CPUs, client GPUs to data centers, CPUs, GPUs. and the Gaudi AI accelerator. Gaudi AI accelerator is specifically for deep learning applications like the generative AI models that we have. I'll cover briefly. This is Gaudi accelerators, how it looks. This is Gaudi 2 AI accelerator. And generally, an Gaudi 2 accelerator comes in as a node. One node have 8 cards in it, right? One mission was called one node, and it will usually have 8 such cards in it. And the hardware specification, some of the things are like it has 24 tensor processor cores, that's the number of cores it has, and it has 96 GB of high bandwidth memory. It uses 7 nanometer processing technology, that's the silicon fab technology, and 48 MB of SRAM. But one of the very important thing is that the 24 integrated 100 Gbps Ethernet ports. It has 24 100 Gbps Ethernet ports built right into that silicon. If you see the competition, right, the competition has to use a separate. Generally, if you're using generative AI models, you'll be using more than one GPU cards for sure, especially for all the enterprise use cases. You cannot work with one GPU card or one AI accelerator. It has to be at least minimum of 8 or something that's being used, right? And for, like I said, for ChatGPT 3, they used 16,000 GPUs. And definitely interconnection, sharing of data between all these GPUs is very much a requirement. And for the competition, what happens is they have to use an external links to link all this, interconnect all these GPUs among themselves and share the data. Then there's actually a downfall, and also it adds complexity to the overall in the building of the infra and things like that, and it can get expensive as well. But the Gaudi 2 accelerator has 24 of it, so that it can actually vertically and horizontally can interconnect all these accelerators, like horizontally within the node, you can interconnect, or vertically within the multiple nodes, you can interconnect using this inbuilt. Each card will have this 24 integrated ports. So it's one of the things. I'll also share certain performance numbers. What we have seen, there are publicly available numbers. So the performance of Gaudi 2 accelerators are sometimes better than A100 or H100. A100, H100 are NVIDIA GPUs that are specifically used for deep learning applications, and definitely they perform better. And the overall cost of this hardware is also lesser compared to the computation. So definitely there are alternatives available. GPUs are not the only way. For majority of the use cases, right, what we recommend all these accelerators and CPU itself, so you don't even have to go to accelerators. Most of the enterprise use cases, CPU itself, Xeon CPU itself is more than sufficient. But there are some time sensitive applications, maybe you have to go with Gaudi accelerators or GPUs, you could use that. Any questions here? So from the performance perspective, there's some these are all the publicly available numbers. There's not you can actually go ahead and verify yourself. The baseline is NVIDIA A100 is taken as the baseline, and you are comparing different models like BERT large model, P5 3 billion parameter model, stable diffusion model, and then Bloom 176 billion parameter model, and Bloom 7 billion parameter. In almost all the cases, you see at least 1.5x improvement in performances when compared to the A100, right? So you can actually use Gaudi accelerators, reduce the cost, also gain improvement in performance. If you are using any specific models, there are also numbers available for Llama, Mistral, and other things that are available in the Intel website. Or if you need help, you can also talk to me after this workshop at any point in time, right? Any point in time, if you're working on anything, you need help for any of your AI deployments, do contact us. My engineering team will help sit with your engineering team, and we can help you on loading all these things onto your hardware. Again, this is an evaluation done by a third party. It's not done by Intel. A third party actually evaluated a stable diffusion model with the NVIDIA H100 and A100 with Gaudi, and you see their performance. Definitely, there's a huge, almost 55% improvement in performance when compared to H100, and 3x faster than A100. So definitely, NVIDIA is not the only way to go for generative AI models. Take your specific models, look for those numbers. Don't go by the market hype or things that are generally available in the market. Go into specific details, look for specific details, what is specific models that you have, and see how this performs to make the right decisions for yourself. Again, this is comparing stable diffusion inference with the A100 and the A10. This is with Gaudi 2 and Gaudi first gen. Currently, we are on Gaudi third generation, just released last month. There's also numbers available for Gaudi 3. Again, we see huge difference, huge performance improvement. Again, these are all done by third-party evaluations and others independent agencies. So it's not like Intel is doing it. It's all done independently being evaluated. It's publicly available numbers. And coming to this question related to power and carbon savings, so this is again one of the things that people do measure, right? It's being actively looked to, especially in generative AI use cases. We have to actually look at the total power consumption because the carbon footprint is a huge matter of concern for everyone. And you see Gaudi AI accelerator when compared to A100 has lesser power consumption compared to the NVIDIA's. And definitely there are tools available. I can share those tools to you and do measure the carbon footprint your AI loads have on the overall scheme of things. Here certain numbers, these are publicly available numbers. I can quickly flash. I don't have to get into the details of these numbers. Just see it for yourself. And Gaudi 3, like I said, just last month, Gaudi 3 is released. Gaudi 3 is almost a 4x improvement in for a B4 16 data type and 2x in networking. It has more number of, I said there are 24 Ethernet ports, 100 Gbps, and it has more. Gaudi 3 has even the double of that. And then the high bandwidth memory is also like improved 1.5x times. And the processor node technology is 5 nanometer. How many of you are aware of what is this processor nodes technology, 5 nanometers, 7 nanometers? So that's actually size of one transistor. One transistor is like, what is the size of that one transistor that is there in the silicon, right? So currently, 1 nanometer will almost come close to one atom. So it's almost very difficult to get there. It's a very high-end technology, and it's currently I think we are around close to somewhere 2 nanometers. And 2 nanometers are like very high-end technology, and the kind of the machine, the entire globe. There's only one company which manufactures that machine that can actually write the center circuits, 2 nanometer circuits on the silicon. It's called ASML. How many of you have heard about ASML? Yeah. So ASML is the only company, a Dutch-based company, and the Intel and everybody are all investors in that company, right? And they have a technology called EUV, extreme ultraviolet. Extreme ultraviolet. We have to actually see a very nice YouTube video to explain how complex that engineering is like, right? You need to actually generate a laser light that is lesser than almost close to 1 nanometer. 1 nanometer is like almost the wavelength has to be close to 1 nanometer. It's almost close to one atom size to write a circuit on that silicon. And it's a very extreme complex technology, and a lot of engineering has gone into that. I think each mission costs around $300 million. One entire mission costs around $300 million. And if you see, right, even if you these Gaudi accelerators and the NVIDIA GPUs, so each one costs you around $10,000 to $20,000 each CPUs and GPUs, right? And even if you're ready to pay it today, it's not available in the market because the amount, the kind of technology being used to generate all this in the fab is very high-end technology and there's a very limited capacity. And that's where it's also a huge demand for things. So even if you have the money, probably sometimes you will not. There's almost a waiting period of 3 to 6 months to get the. If we have to, let's assume that we have a requirement for using Gaudi 2 accelerators. Intel will simply not give you the Gaudi accelerator. Because a separate team will come and evaluate whether what's the business use case, whether it actually makes business sense, and all this evaluation is done. It will take almost 2-3 weeks for you to get an access to the Gaudi accelerator on the developer cloud. GPUs, again, the GPUs 3 to 6 months is the waiting period for the GPUs. And so there's a lot of demand for GPUs. So one, again, this also brings to the thing that you should start utilizing your existing things, right? You should not be waiting for the hardware. You can use your existing CPUs itself. Xeons are easily available. You could use your Xeons to do most of your work. Some of the portals, quick help for Gaudi. Probably you can take a snap of it if you want. Can refer it later. Any questions before we move forward? Sorry, you are taking a snap. Okay. Coming to the Xeon 4th Gen, right? Like I said, the Xeon 4th Gen has almost 56 cores in one silicon die, but it also has accelerators. Like I said, there are many accelerators. One of the accelerators of importance for us is this AMX that I was talking about, advanced matrix extension. That's actually an accelerator that you need to do some small code changes for PyTorch or scikit-learn. XCBoost, you don't have to actually do any code changes. XCBoost, if you're using the open play, whatever is available in the open, you could use it and you can just start using it. But for certain, most of the other frameworks, you should do certain changes to use this accelerators that are available for dedicated for AI workloads and start utilizing all those accelerators. Again, there are other accelerators like the data streaming accelerator, in-memory analysis accelerator, or the quick assist technology. Probably these are all not mostly high performance computing related accelerators, not relevant to AI, but we'll not go into in depth of those things. But if you are interested, you can explore those things later on. And some performance numbers for Llama 2 with Xeons. There's single socket Xeon. With the two different types of process being again both of fourth generation and multiple token size 32 token 128 tokens 100,000 or 200,000 2K token size. B-float 16, how many of you are aware of what is B-float 16? What is the data types? So generally, if you are normally going with training or inferencing with whatever is openly available, it's mostly you'll be using floating point 32. FP32 as the data type. But FP32 is a huge data type, and that actually can have a huge impact on the overall inference time, training time, cost, and everything, right? What most enterprises if try to do is they try to reduce the data types, or they might use or an optimized data type. B-float 16 is a 16-bit data type developed by Google. They propose this data type, and these are some of the this is one of the most popular data type that is being used for majority of generative AI workloads for both inferencing, fine tuning, or training. You might always hear about the data type, so be aware of the data type as well. Based on the use case scenario, you might want to use int8, FP16, or bfloat 16, or FP32. So be aware of this data type. So data type also matters. For majority of the data type, use cases, bfloat 16 is very good. But if it's a really sensitive thing and you need to have a higher accuracy precision, probably you should go with P32. But that again translates to a higher compute cost. And yeah, floating points, like again, the answer to that question of why GPUs are good at accelerators, because again, this most of this calculation happens on floating point, and generally GPUs are good at floating point. CPUs can do floating point because they are a general purpose CPUs, they can do it, but GPUs generally efficiently do it. Even with an int8 as the data type, this again are different numbers with single circuit. And this again be a lot of open source CI libraries and frameworks that we were talking about. Like we have the modeling SciPy, NumPy, Number, Pandas, and XCBoost, TensorFlow, PyTorch, Intel. All these things mostly comes under the bigger bracket of one API, which is an open standard. And a lot of these optimizations are available as part of the one API specification. Do use this optimization as well. Don't just go with the standard approach. We use the optimizations so that you see improvement in the performance. And then there are some specific paid tools like Converse.io. Converse.io is an paid tool from Intel. It's actually an MLOps pipeline. It helps you build MLOps pipeline for data acquisition, data cleaning, data ingestion, training, and inferencing. Then there is Getty. Getty is also a paid tool from Intel. It helps you build computer vision models easily. And coming to the developer cloud, so Intel has a cloud platform called the Developer Cloud. It's available at cloud.intel.com. You can freely sign up. I'll recommend everyone to create a free account for yourself. There are two things there. There is a shared instance that is available for free, just like your Google Colab. I think as part of your course, you learned about Google Colab. So there's also something similar called similar here as well. You could use that for free. And then there are dedicated instances of Xeon CPU, both fourth and fifth gen, and GPUs as well as Gaudi accelerators. That is actually paid on. Probably if anyone is wanted to try any of your enterprise workloads, you can approach me. I can actually give you some credits. I could use that credits to evaluate those models, and if you need any further help, I'm ready to help on that. So it's available on cloud.intel.com. Let me see if I can quickly walk through. So go to cloud.intel.com. You will go to the sign-in process and create a standard account. It's a free account. Enter your email ID, both your personal or enterprise email ID, or use it and create an account. I'll go to directly get started. Yeah, you can go to get started, create a free account, a premium, or things like that. You might sign up as a standard user to begin with, and if anybody is interested to evaluate it further, I can let me know. I can give you some cloud credits, and for using cloud credits, you might want to change your account to premium. So there's an option to change your standard account to premium account once you get the cloud credits. So I will sign in directly now. Since I already have an account, I'll sign in. You will use the standard sign-in. Since I'm an employee, I have this privilege, additional privilege of using this additional option. So once you log in, it will land you into a console page. It's a standard console page. One thing that you might ought to be aware of is your account settings. You might see an additional option here called upgrade account. When if anybody needs cloud credits, if I give you cloud credits, click on that upgrade account and upgrade your account from standard to premium, and then use the cloud credits. And then we will come to hardware catalog. Here you can see the dedicated instances. You see the fourth and fifth gen, and then Gaudi. You might not see the Gaudi accelerator. Gaudi is not easily, like I said, it's not freely available. If we need Gaudi, there is a separate evaluation process that goes through, and only then probably it will be. Since again within Intel, not everybody will get access to Gaudi. Only people who are actually working on those things will get. I had to go through this process for almost a week to get access to the Gaudi accelerators. GPUs you'll get easily access, and then there is also high bandwidth memory Xeon process. You could select any one of them, and there's a charge. These are all charged instances. There's a different types of instances. Like there's a small instance with 8 cores. There's a full bare metal machine with 112 cores and 2 sockets and 512 GB of memory. And the cost is around $3.62 per hour. So if you have any training needs, huge training needs, I generally recommend you can use Developer Cloud to do all the training and things like that. So that's very cost effective for your organization. And there's a easy way to set it up. Once you set it up and launch the instance, you'll get an console access like similar to other cloud services. And remember one thing, this Intel Developer Cloud is not in competition for AWS or not an alternative for AWS or GCP or Azure. It's actually kind of like the name suggests, it's meant for developers, it's not meant for the general public. It's meant for developers like you and me to evaluate the hardware. And for the free thing, scroll down here on the menu and there's something called training. Click on the training. There are a lot of very good examples to explore. I recommend all of you to explore all these examples. I think some of them you have gone through this course certification. So there are very good examples on that. You explore all that. There's also an example to migrate. If you have a CUDA code, you want to migrate it to the SQL Open Standard 1 API standards, you could use these examples. And for Gen specific examples, there's a lot of examples like fine tuning, stable diffusion, image to image generation. Other examples are available. And just click on the launch button. Say, for example, if you can take any of this, and this will actually kind of launch like a Jupyter notebook, which is very similar to Google Colab. How many of you are aware of Jupyter notebook? Yeah, I think majority of you are aware of it. It's a very simple web-based interface that you can use to evaluate your Python codes. It gives you a lot of access. There's a Python notebook that has a concept called cells. You can select a cell and click this play button. Play button will actually run that cell. Before you run that cell, probably you might want to choose the kernel. Based on the type of kernel that there are multiple kernels like a PyTorch kernel or a TensorFlow kernel or BASE is one API based toolkit. If you are using any one API based toolkit related libraries or frameworks, you could use the base kernel. So select the appropriate kernels, or you can install your own kernel and start using it. I think rest of the standard features, you have an option of browsing your files and things like that, and other things to take, or you can upload things. Click on the upload, and you can upload any of your data, or download any of these things as well. Yeah, so I will recommend at least do try out all these examples since you are all they have gone through the certification. Do recommend use all these examples. See, and some of these examples also has this working demos on how to use the optimizations, right? Like the Intel extension for PyTorch or Modin, things like that. And you can see the performance difference, and we can appreciate how simple changes from developers will have a huge impact on the end pipeline. So we'll talk some industry specific use cases. Again, this is not an exhaustive list, and there's just a couple of popular use cases. I have just tried to highlight it here. From an automotive perspective, all this time we're all talking about the cars as a vehicle, right? In the way we're all going talking, but there's a new term that is being emerging. It's called laptop on wheels. Probably in another few years, cars and all these vehicles will not be called as cars. Right? They'll be called as computers on wheels. As you see, even this at this level itself, like the example of a punch, I said, right? A Tata punch, right? This is a very basic model costing around 8 to 10 lakhs. That itself has software updates coming up every time. Software updates are something that is never existed for our automotive industry, right? Once the automobile comes out of the factory, that's it. Whatever software it had, that is the software it is going to have throughout its life. That scenario is going to change now. Now it's going to be a laptop on wheels where software updates keep being pushed into these automobiles, right? So from the perspective of how generative AI can be used in the software industry, one is definitely a lot of generative AI related models are being used to give the advanced driver assistance apart from the ADAS systems that you might have. I already know a lot of our customers are already talking to us to implement many of the generative AI use cases that is beyond ADAS into the automobile. And the future looks very interesting. Maybe 3 years or 5 years down the line, the kind of automobiles that you see in the market will be totally be different from what we have experienced so far. That's a good thing. We should be. We are lucky to be in this transition frame. We're able to appreciate the old technology and the new things that are going to change. It's not like some minor upgrades that's going to happen. It's going to generally revolutionize the entire automotive industry. Already, we are seeing it in terms of how the term is being called as laptop on wheels. That's going to be the term that is going to be used. And from the perspective of an enterprise, automotive enterprise, if an automotive, many of the automotive customers are also using generative AI models for their developing their own products. People who are in the automotive industry, they know that generally a new car development takes 8 to 10 years for a new car to be out in the market. But with this generative and other things, it's reduced to less than 2 years. Less than 2 years, you have the brand new platform being developed, complete end to end, right? And that's also one of the key reasons many of the new age automotive companies are better valued than the traditional automotive, right? Say Tesla is now almost $1 trillion company. That's not because that they're selling more cars than Toyota, or more cars than GM or Ford, right? Tesla is more valued because the kind of hardware, software that they have, the kind of AI software that they have built into their systems, and the kind of IP they own. That's why it's valued as like a $1 trillion company, much higher than all the top three other automobile companies combined. So definitely all this generative AI in general, and probably generative AI to be in a couple of years is going to add a lot of value to companies' evaluations, companies' IP holdings, and definitely should start looking into those aspect. From the telco perspective, we have probably many of you might not be aware like how this telecom maintenance happens, right? And there are a lot of technicians who keep constantly maintaining all these telecom towers and things like that. That's a huge operation. That's one of the biggest expenses for all these huge telecom operators, right? We need to constantly keep adjusting the antennas, maybe maintaining those base stations, things like that. And definitely, generative AI can actually help in optimizing the entire operations, right? How do you select who is the right technician, right? In one tower itself, you might need different types of engineers to handle different types of things. So there might be a radio frequency engineer who can deal with all these antennas. There must be a network engineer who can do only all the networking related part of it. There's a civil engineer who can actually work on the structure of that antenna and things like that. There is a computer software engineer working on the base station, things like that, right? So you need to identify what's the problem that is happening on the telecom towers and define who is the right technician from the right location. Say, for example, if the problem is happening in, let's say there's a tower in IISc campus, we don't want the technician who is in Hosur to come down all the way to travel here to fix that issue. You might want to optimize that your entire operation to see who is the closest person within this campus who can come and fix it in a more cost effective way. So definitely generative AI is going to do a lot of value addition there, optimizing the entire operation. And then the one was the customer service systems that I was talking about, like the Lenovo Deep Brain is a very good example. Do explore that; it's very interesting. We need to probably should also try it out to build your own virtual assistant that is so realistic. Maybe you can use a tool called Unreal Engine. Unreal is a gaming engine. It's a gaming engine used to render very realistic looking human. It can render all this realistic looking humans. You could use those engines and see how you can connect to an Llama 2 model or something to build something similar to Lenovo. It's a very complicated task, but do try this an interesting exercise. I'm also trying it out, so it might be of interest for you. From the perspective of banking and finance, we have, like I said, the fine tuning, the investment advice example that I was quoting, right? You could use all this investment advice data that the companies might have and fine tune those models and use it for their specific use cases. That's going in an example. And also one of the other operations that are getting digitized is the summarization of large documents and things like that, especially when you're going for a loan, and you should have known the kind of documentation is involved. And these generative models can actually summarize that in a very efficient manner and probably reduce the overall time required to generate all those documents or approve the loans or fasten up the entire process. Manufacturing, a big innovation that's happening here is the product innovation, right? Newer products are getting assisted with generative models to develop newer products, right? One example probably I can give is the fashion industry, right? Earlier, the fashion industry, all these fashion designers, they have to do all this fashion designing. Nowadays, one example probably I can quote is there's a company, fashion designing house in China, who was also a customer. It's called Style 3. I think it's called Style 3. They use stable diffusion model to actually generate new fashion designs for their this thing. So instead of a human fashion designer developing a new fashion that takes weeks or months to do that, now you could use stable diffusion. Only if I have time permits, I can actually run through the stable diffusion model later. We'll check the time and then we'll do that. And from the perspective of supply chain management, again for manufacturing, that's a huge concern. Any large scale manufacturing has a huge supply chain that needs to be efficiently managed. And generative models can efficiently do a lot of analysis to fasten up the entire pipeline. Healthcare is also the significant sector where generative AI models are having a huge impact and a lot of demand is happening. And it's also one of the sensitive area. Probably these are the areas where you might actually sacrifice power or carbon ratings and things like that, and you should go for the absolute performance, absolute accuracy. And doctor assistant platform, caregiver support tools, these are mostly from the US or developed market. Some of the platforms being built for the healthcare industry. I think mostly we are done. Probably some of the links so you could actually. How are we on the time? So much more? Okay. Yeah. So these are some of the important links. Probably can just capture those links. There are a lot of open source models available, model references are available from Intel, which are actually optimized for the Intel hardware. So if you're using any of the Intel hardware, Xeons or Core series, do go through these links and use those models so that they work more efficiently for you. Open to Q&A. I have flashed my LinkedIn address at the QR code. If you want to connect with me later on, you can connect with me, and we are open for questions now. Feel free to contact me after all these workshops, after this course. If you have any of your enterprise use cases where you are working on enterprise, your enterprise needs any help from Intel, we are happy to help you there. Questions before we wrap up for the day? At least this session, not for the day, at least. Okay, good. Thank you. Thanks, everyone. Thank you. Thanks for the time.